So we're going to return to the single responsibility principle, chapter 5 in this unit, and we're actually going to spend some of next unit looking at the same code. So we're going to go in this chapter, and first I'm going to review quickly what we did last week. So last week we started with a method here that was all one, all the code was in one long method, and then we refactored it for clarity, and we broke it up in a couple methods. And then so that big long process trade method went into a read trade data, parse trade data, and store trade data, and we broke it up. And then the parse trade data was broken up in a couple different parts, and then we used this IEnumerable length, and we went through this stuff. So we did that last week, if you recall, and then we got down to this refactoring for abstraction. That's where we're going to start today. So if you remember the project last week that you started with, again, we had a main program, we had a trade processor, and we had a trade record. And in the trade processor, we made changes to it to do that. We also added a database in here, an MDF file that we could run this, and during the assignment, hopefully you created a number of tests here. We gave you a method to count the data records, and then you created hopefully a number of tests here to do things like try out if no test file was run, or an empty test file, or so many trades, and then you would count to see how those trades were done, or poorly formatted trade stuff and stuff like that. And we're going to work and modify that today some as part of this next assignment. So this week we'll return to this code, and we'll make a number of changes that the book illustrates. But first, let's go on to this next part, refactoring for abstraction, and look at how that works. So here the textbook has taken our three parts and put interfaces in between them. So we have our trade processor, which was calling a read data, trade data method, and then a parse trade data, and then a store trade storage stuff, calling three methods here. But we're now going to break those methods into their own classes, and then put an interface in between them. And so we walk through this. I can show you quickly kind of how this might work. And then we'll actually just, it gets kind of complicated, so we won't actually do all this, but then we'll open up the code that the text provides for this second part and look at that. So I'm going to take this code right from the textbook. I've included links here if you don't have them handy. So this is the code that included with this textbook course. Refactoring for clarity is the first one. It's not as complicated. That's where we ended up last week. And refactoring for abstraction is the one where we're going to this week, and doing both of these. Now, just be warned, when you do the assignment for this week, I have slightly different versions of these that you'll be downloading from GitHub. So these are just to look at for while you're learning this stuff. So first we'll look at this refactoring for clarity, and what we want to do is add these interfaces. So we're going to add an interface to this get trade data method that will get the trade information. So if we go back into trade processor, if you remember, one of the first things it does is it calls read trade data and passes in a stream and gets back an array, or an enumerable of lines, strings. And here's that method right up here. It opens up the stream that's given for input, the file in this case, and then it reads each line, grabs each line and adds it to this list of strings, and then returns the strings. And then as it returns, it's recast into this IEnumerable type, which is a generic list of strings. So we're going to pull this out into its own class. And that's what the textbook does. And again, we'll just do this once to see how it works. So I'm just going to add a class here. Add a new item. We'll add a class. We'll call it stream data provider. and create that class here. And then we'll just take the code here and this whole method, in fact, and we'll copy it out of here and put it over here. Now in the textbook they actually rename this to get trade data instead of read trade data, but I'm just going to leave it here as this for now. Now let's see, there's an issue with this. I have to input stream.io to get the stream stuff working, and then I've got that set up. Now we're going to modify this a little bit. Rather than passing in a parameter here, we're going to put that in the constructor. So we're going to add a constructor here. So public, and then just name it the same as the class. So it'll be a constructor. And we'll move this parameter up into that class. So when we create one of these, we'll create it with a stream, and then we can tell it to read the data from that stream at any time. So since we're doing that, we need to keep track of this stream information. So we're going to declare a variable for that. Now your textbook tends to declare method variables at the end of the class. I'm used to doing it at the start, so I'm just going to put it in here. So it's just going to be a private variable stream, and call it stream. Now I've got to watch, let's see, this can be private, this should be public, and this should be public also. So we can call it. So we've got two public methods, a public constructor and one public method, and then this private data. We need to keep this data. We're given to it during the constructor, and we're going to use it down later on here. So we need to keep it around. So we're going to say this dot stream equals stream. So we're given a stream here, and we're going to save it to this stream. Now I find it confusing. A lot of people do this. They use the same variable name here, and then if we just say stream, scope says to use this stream. If we say this dot stream, that's that stream. In fact, highlighting will show you which stream it is. I sometimes find this confusing, so I'm in the habit of calling this like new stream and this new stream, and then I can say things like stream equals new stream. It's just different programming styles. They're both the same. You can decide which way to do it. Okay, so now we've created this class. We have a constructor, we pass in the stream, and then we use this. So now we can actually call this in our trade processor. Now we were just calling, let's go down to the bottom, this read trade data, and that's no longer in this method, it's in another object. So we're going to have to declare an object of that type. So I'm going to declare a variable in here, private stream data provider, trade data provider. So I'm going to declare an object of this type and put it in here. I'm going to have to call a constructor for that, so I'll say, well actually I can do that right up here. I can say equals new stream data provider, and I want to pass my stream into this, into my constructor now. So I don't need to pass my stream here into it. I pass it in when I do the constructor. And then now when I call this read trade data, I have to call it using this object. It's now defined in this object, so I have to, whatever my object name is, I have to call it there also. So, okay, now we have a couple errors. Okay, I just had to wait for the compiler to catch up and compile everything. So now my errors are cleaned up. So again, I'm declaring an object and then calling this method here. Okay, now I figured out, I got my errors back. So I was thinking I needed this private, but inside methods, of course, we don't put any private. We just declare the data type here. So I've got this declared here and ready to go to work with. So now I create a stream data and pass it, and that should call this, create this object. This is the constructor, and this is the method here that I've done. So that's my basic kind of interface, no, or method here, but now we're going to stick an interface between this trade processor and this interface in this method, so that we'll make a generic interface that this will support, and then other method we can then create other data providers that can implement that same interface, and then we can substitute them in and out here as needed. And in fact, we'll do that as part of the assignment this week. I want to put an interface around this object, this stream data provider. I could just define a new interface. I could just go right click and say, add new interface and name it. I think there's a shortcut here. There's different shortcuts here. I think if I click on the class and do quick thing, there's an extract interface that'll shorten things up a little bit for me. By default, we want the I in front of the interface, but I'm going to use this naming convention the textbook uses, I data provider for the generic one, and then each of the actual data provider will be like stream data provider or web data provider here. So I'll do that. And there's only one method in it, and we'll do that. So I'll create that interface. So this will create this interface. Remember, now the constructor I'm not worried about. The only thing I'm worried about is the this read data method, and that's the only method in the interface. So it's a really simple I data provider interface, and we only have one method here, and it has no parameters, and it returns one of these generic I numerals, a generic list of strings here. And then here we'll say that this class implements that interface. So that's all. When we did that extract, it pulled that interface out and inserted this here so that we're implementing that interface. So that's good. Now we're going to make a couple more changes to when we call this to just look at some different ways of setting this up. One is we're going to move this code. Well, we'll actually go open the code, but we'll look at how it works and see how this code is a little different from what the textbook does. So let me open up what the textbook does here. So now I'm going to look at this final solution the textbook does. I call it refactoring for abstraction. So I'm going to open up that. And that's what's given in the textbook. So the textbook walks us through this, creating this interface, what we've done. And this is their trade processor. It's more complicated. It pulled out all the code in the trade processor to different routines, and you can kind of see how we've begun to do that here. We had one method up here, and we pulled it off into its own class and just created an object of that type. And again, we can go through each of these methods up here and pull them out into their own classes. And then define an interface between them. So that's what they're doing here, and this is what we finally end up looking at. And here's our trade data provider, stream trade data provider that we just looked at. And again, here, this is almost the exact code we just did. Here's our constructor where we passed in a stream. Here's the code we copied from the other thing. And again, they keep the stream around, but I declared this at the top, they declared it at the bottom, but the private variable is here. So we're given a stream in the constructor, and we use that later on in this get data provider, and it implements this interface here. And then we're going to do the similar things for the trade processor. But the trade parser is a little more complicated, because if you remember in the original code, the trade processor, the trade parser, I should say, called two other methods. So parse trades went on and called validate trades and map trades to data records. So validate trades checked all the trade data, see if it was good, and also logged some messages. And map trades to trade records took all the strings and created a trade record object from that and returned that trade record object. So again, we have those two methods, and so again, they're showing that this simple trade parser is going to implement two more interfaces, and we're going to pull both of those objects out into different interfaces. The last thing we're going to do is we have that logger routine. So again, this lops through that previous thing, but then we have this logger routine that a couple of these methods use. And so we're going to pull the logger out into its own method and define an interface to it. And they talk about how then you could use a different program and an adapter object, a generic, a well-known logger program. We're not going to do that, but we will pull the logger out into its own method and see how that works here. Um, so let's look at the code that they do a little bit and walk through it. Um, so let's see. This is the main program they run. And again, it's changed quite a bit from before. Before, the main program had to just create a stream and then create a trade processor and pass that here. Now we're doing a lot more. We're creating a data provider and passing the stream to that. We're then creating a parser, and then with the parser we're creating a validator and a trade mapper, and we're passing both of these, the validator and the trade mapper, to the parser so the parsers can be set up to use those, and then that lets us substitute a different mapper or a different validator into our parser. And then we have something right to the database. ADO.NET is the name of the common database architecture in C# and Visual Studio. So ADO.NET is just the name of this. And we're creating that. And then we also create a logger here. And anything that needs to do logging, we pass the logger to it, so it knows what methods to use for the logger. Finally, we create a trade processor and we pass it in the trade data provider, the trade parser, and the process trades. So, and the trade storage stuff. And then we just tell it to parse the trades, and it'll use these three classes to do the parse those trades. So again, we call a constructor here and pass the objects into the constructor that we want. So if we look at trade processor, the actual code for that, when we say process trades, it says just get the trades from this data provider, parse the lines using this parser, and then persist. That means, that's just the new name for this method, for store the data in the database. And here's the database storage routine for doing that. And again, so we call get trades and we get a array of strings. We take that array of strings, pass it to our parser, which validates them and makes objects out of them, and so we end up with an array of trade objects, trade records. We pass that set of trade records into this database storage thing, and that writes them out using SQL to the database. So that's our object here. Now things are a little different in that now during our constructor we're passed in the trade provider we want, the parser we want to use, and the storage we want to use. So this makes it flexible. We can pass in different trade providers. We can pass in different storage things. So we could pass in, if we needed to store this not in a database but a different type of database or an online database, we could write in a different storage provider and pass it in there, and this processor would still work. Same with reading. If we're going to write in a web data provider here that'll read this information from the web, we can just pass that in here and work with that. And since we're passing those in the constructor and we need to use them later on, that we need to store them here, and so we have these local variables that store those those objects for us that we then use during this one process trades method. Okay, and then each one of these, let's just look at, again, we've already looked at the stream trade provider one, and that's just like we have. And the data provider is actually in a different, they're showing that this can be in a different solution. So here's our ADO data provider. And again, this sort of code is very similar to what we used before. It's just in its own method here. And we have a constructor that we call here, and we keep the logger around. We pass that in because we're using that to log some information here. So we've got the main program, we have the console logger, and then we have these different methods here. Validate trade is a little more complex, or parse trade calls something to validate the trade and something to map the trades, and so it's a little more complicated. Similar to before, we pass in a trade validator object and we pass in a trade mapper and store those in local variables, and then we use those around. Now a lot of these objects are declared as private variables here. They're marked all read only because it forces us to only set them during the constructor. here, and that's why they're all passed in during the constructor. So, now finally, there's a contracts area, and all the contracts here, these are all the interfaces. They're all very simple, but they just specify the interfaces. So read through the text here, and it walks you through. Again, it explains this in more detail, but hopefully I've given you enough information so that you can read through this and make some changes. Now finally, there are some requests here for, well, what would happen if we wanted to make this change or that change. And during the assignments, we're actually going to do some of these changes to both the first version and the second version of this project, and see how that works. Now we're going to stop here when we get to the decorator pattern. This is a more abstract version of what we're doing and how we set it up, and we're going to save that stuff for next week.